Hey, good afternoon. It's July 2nd, Tuesday, around 1 o'clock. I'm a little late starting. I lost track of time in between streams, and I was thinking about something for a short post or article or something like that later on. And holy cow, time got away from me. But here I am. My name is Rob. I am that developer dad. And this morning we did some requirements analysis. We broke down what is likely to change over time versus what concepts in our townsfolk generator are going to be shared throughout that application. And I think it's time that we started doing some diagramming. So I'm going to pull my controls over to the other screen, trying to maintain eye contact. I got to look over here, and we got to go to the screen share. All right, here we are in our GitHub GM Tools MVP project, and we've got one item left in our to-dos, and it's to use the requirements analysis we did this morning to create our first draft static design. Let's pull this into in progress. All right, now how are we going to do this? The first thing we need to do is talk about what components we are going to have in our system. And this is going to be a little bit of talking more than diagramming just yet. So what I'm going to do is I'm going to flip back to the single camera. Maybe. Here we go. All right. So when we're building software, we tend to work in the concept of components. And under the design methods and teachings that I've learned, we have 5 primary components. Number 1, our systems have clients. Those are applications that call into and make use of the use cases that are exposed by the system itself. Number 2, we have utility components. Those are components that can be used by literally any of the other components in the system. They don't have business value, but they manage our cross-cutting concerns for us. Things like logging, pub sub for messaging type things. I've seen rules engines fall into the category of a utility versus an engine. The jury's kind of out on that. I've seen a lot of discussion and arguments both for and against that. Then we have resource access. Those are components that query a database or read and write files from our file system, or access a remote API, perhaps receive data from a remote source like a IoT device, things like that. Then we have engines. Engines are components that do compute for us. They're the ones that handle logic, like analyzing an object and maybe determining what current state of that object might be in terms of a workflow, or whether it's valid or invalid for the operation it's about to engage with. Certainly anything that involves math or calculations, sorting, indexing, things like that, those are all performed by engine components. And then finally, we've got managers. Managers are basically just simple classes that call out to engines and resource access components and call the methods on those other 2 components in the order that they need to be called to execute some use case that we've defined. Let's we'll talk more about each of these component types as we go, but I think right now it's time to start doing some diagramming. Now for that, I'm going to use draw.io. Why am I using this instead of Lucid Charts or Visio or whatever? Oh gosh. Yeah, let's update it. All right, here we go. A new version, let's install it. Come on. It quit. Is it installing? Oh, here we go. Oh, that was a nice experience. Okay, so we're going to create a new diagram, and we're going to call it Townsfolk Gen Static Architecture. And we're just going to make a blank diagram because all we need here are boxes and arrows. So there's a reason I'm using draw.io. First off, it's free 95 and it works on my Mac and it has all the features that I really need. So let's add some text first. Voice thing. Townsfolk generator static architecture diagram. And we'll pull this guy up to the top. And over we go. We'll make it use the whole thing. And we'll give it we'll fill it with black. Fill it with black. Apply. And that stuff's good. Let's pull that all the way up to the top. Pull this down. And finally, I want to use a bigger font size for this. Let's go to 18. 18 is good. Static architecture diagram. Now, I tend to use some color coding when I am defining my components. So right here we've got this. It's going to be a green background and it's text. Where is that? Text. Edit style, edit data. Yeah. Just double click. And let's call this just clients. We'll bump that to 16. And let's make the font color black. Apply. Cool. Now we need a line because this represents a logical or physical boundary between our layers. And yes, we are going to design this as a sort of quasi-layered architecture. So we're good there. Next thing we have is another rectangle. We have identified for our solution that we have rule set. Yeah, so we've got a rule set. This is a resource. And our component that accesses the resource, we're just going to call it rule set access. We've got another component that does access, and that is NPC access. All right. We're going to need some resources to represent these things. Now our rule set, we're going to define as a class for the time being. We're going to hard code the data for our 5e SRD rule set. And I'm going to use a slightly darker blue. And before I carry on, I want to turn those black. This one too. Here we go. Apply. Change this to rule set data will be hard coded as a class for now. Then I bet we've got something over here that represents files, and I can't remember all of my shapes. Data storage, ands, vertical containers, lists, internal, come on, document, tape. Let's just go ahead and call this. No, there's definitely a file glyph somewhere. What's this? Multi-document, stored data. Let's just pull this here and we'll use this. Make it dark blue. App data, NPCs stored as files. Ooh, what did I do? Ha! Oh no. Here's our document back. NPCs stored as files. All right. Next, we need something to represent our dice bag. Whoops. Let's get rid of that. Ah, no, we'll stuff this up here. Now, dice bags, or engines, I usually like to color those orange. Dice bag. And we're already black. And managers, I like to make those yellow. Townsfolk manager. All right. Very good. So we've got these things listed out conceptually. Something that I've gotten into the habit of doing. No, I'm not going to do what I was about to do. I was about to put a capital letter I in front of each of those components. Because in C#, I tend to write my interface files first, and then I write the actual classes that implement those interfaces. But I'm not going to do that here. And the reason why is that this type of thinking that we're doing here doesn't only apply to dotNet applications. The type of planning that we're doing here, where we're working out the static architecture and we're figuring out which components are going to hold which code and how those components are going to talk to each other, it's not just a dotNet thing. It's not just for C#. These concepts apply no matter which language you're using. Of course, they apply in object-oriented languages like Java or heck, even C++, Visual Basic, any of the flavors of Java. They also apply in JavaScript, Python, so on and so forth. We can do this type of encapsulation in almost any of the modern popular programming languages that are out there. I think even PHP allows us to do this, but I'm not really familiar with PHP. I think I've looked at PHP code once, and that was many, many, many years ago. Point is, this type of planning and application code design absolutely applies no matter which language or which framework or which stack you're working in. Let's go back to the share. So we're not going to add the I to these because we're not necessarily just targeting C#. Well, we are. We're going to target C#, but let's keep this nice and generic. Now, let's talk about who can call what. We are going to use what's considered to be a closed architecture. And I should add a couple more things under the utilities column. Utilities are purple. Now for here, logging. Whoa, that's a square. V. No, we're not going to mess with serialization yet. We don't have to mess with that yet. So right now, the only utility that we have is our logging utility. I'm not adding things like PubSub or messaging or anything like that because, frankly, for this use case, for this MVP, we don't need them. Utilities. Let's make that bold. And I'm going to add another line, dotted line right over here. Oh, what are we doing? Stop that. Go away. That's silly. I want to grab the whole thing. And I'm just going to take this. And hopefully this vertical dotted line suggests to us that these utilities are available throughout. All right, let's talk about the order in which things work. All invocations within our system only happen downwards. And I want to color that green. And let's add some text to that. In fact, I want to make this arrow a little fatter, if it'll let me. Will it? Are you going to let me make you bigger? Nope, just the arrowhead. Oh, here we go. No. Flow. Now I'm going to turn this sideways. Pull it in here. And I'm going to turn the fill. There is no fill on that text. Background color, let's make it go away. Can we make it go away? I don't think we can. we can make it match. There we go. And we can make the font color, let's make that black. Apply. Oh, jeepers. Fill. We'll just make the fill match. Come on. Here I am struggling with my tool set again. There. It's a little janky looking, but what the heck. Oh, you know what? Z, let's undo a lot of this crap. This, delete it. I wonder if it'll let us flow. Haha. All right. So, what this means when I say we flow downwards, the client will call a method on the manager. The manager will call methods on our dice bag, our rule set access, our NPC access, all that stuff. We never call up. Ever, ever, ever. And managers never call side to side. That's called using a closed architecture. What's this? Somebody just posted something. Cheap viewers on Cutley. Yeah, you know what? You're spam. Spam, come on. Bye-bye. Tweak.org. You're out of here. We don't need spam. Okay. So clients call down. We never call up. We never call across. Only ever down. Now, in more advanced scenarios, a manager might invoke a method on another manager if we have to trigger a secondary use case while we're executing the current use case. In this case, we're not going to mess with that. We're just going to go straight down. In addition, the level of volatility within each component decreases as we flow down the chart. Our resource access components, those shouldn't change very much. And when I say volatility, I mean delta volatility, change over time. Our engines tend to be pretty stable. The code inside our managers, that because the order in which we might invoke the different capabilities, which capabilities do get invoked, which capabilities don't, that can change rather frequently. And the API, the interface, the contract exposed by the manager, that's not going to change very often, but it's pretty easy to version that and let newer versions of the clients call into the newer versions of our manager classes and so on when they need the more advanced capabilities. So resource access needs to be pretty static. Engines can have a little bit more wiggle room in terms of change over time. The code inside our managers, we can almost consider that to be throwaway code because all it's doing is gluing the orange and the light blue components together. Now, I've got things separated out by layers, except for one. And I got to bring another layer separation line down in between our logic, and our resource storage layer. And let's add some text here. Oh, goodness, what are we doing? Stop that. I need to select nothing. Heading. External processes that use our public API. And I'm going to put public in quotation marks. Nope, I'm not. Published API. That's a far safer. And I'm going to add another piece of text here. Let's call this the consumption tier. And yeah, we're loosely basing this on N-tier architecture. Let's make that a little bigger. Here we go. And let's fix my typo. So consumption tier. And I don't like using the word tier here. I'm going to change that to layer. And a layer may be a physical tier, or it may just be a logical tier. And I want to set that off with a slightly different font color. Still something bright. Let's use 80s monitor orange. I like it. Now this guy and this guy, we're going to copy and paste and pull them down here. This forms our logic layer. Internal processes and components that are composed into our features and exposed by our published API. And some of the language I'm using here might be a little bit confusing because API has become overloaded over the years. And API stands for Application Programming Interface. It doesn't necessarily mean a REST API that you would call from a web page or a publicly available web service that you would call using RPC techniques from a web service or an application or a program somewhere, that kind of thing. All it means, I'm using it in its purest, most basic term, is Application Programming Interface. What methods do we call on the objects when we need to invoke their functionality? Finally, down below, oh goodness, what are we doing? Let's left justify as well, just to keep things tidy. Logic layer, copy, paste here, move it up. We're nice and aligned. And this is our, let's just pick on one. Here we go. Data layer. And these are the physical media where our application data is stored. And I think we've got ourselves a finished diagram. I want to just tighten all of this stuff up a little bit. So let's grab all of that. And can I scroll? Yes, I can. There, we're going to pan. And we're just going to nudge all of this up closer to our header. And I'm going to pop over here. Here we go. And let's fix this text. I want to make the background color the same as our arrow. That didn't work. Oh, draw.io. Why are you being silly? Background color. Let's go with the same as our arrow. Try it again. All right, that doesn't want to behave for us. That's okay. I do want to take the font size here, make it a little bigger. I don't know why it's not cooperating with me. I might have the wrong thing. Here we go. And the text. Ah! Escape. Oh, what are you doing? I'm just going to delete this whole thing. Goodbye. Let's try adding that arrow again. We'll add it from scratch. All right, now we'll make it a little fatter. All calls flow from top to bottom. Now let's grab this, turn it 90 degrees on its side, and let's center it in our arrow. Now we can make our font color black. Apply. Oh, jinkies. What a comedy of errors. That's okay. Apply. Background color. Let's try that lime green. Apply. Now, let's make our fill that green that we picked. That's our line color. And we'll pick that green again. I hope I picked the same one. Close enough. Close enough. I'll come over to text. Let's make it bold. That didn't do anything for me. Bold, I say. Why are there borders? Who cares? All right. This is why a lot of architects hate diagramming. File. We're going to save this. And where's it wanting to put it? articles, blah, blah, blah. You know what? We're going to save this into our GM tools in the docs, images. We'll save it as a draw.io file here. Save. We're going to export it as well. Let's take a look at our properties. Locked, compressed, cancel, whatever. File export as, let's do this as a PNG. Include a copy of my diagram, all pages, only the current page. Appearance dark, transparent background. We don't want the transparent background. Zoom, border width, size, diagram. Yep. And let's export it. And I want to put this also doc, images. And I don't want to add the draw.io .png. I just want the PNG. Save. All right, let's navigate to that and make sure it doesn't look like 5 dog turds in a baggie before I bring it into our architecture drawing. All right, this actually looks okay. I can live with that. And we're all saved. We can quit this. Bye. Let's shrink that down. Shrink it down. I don't see any source control changes here. And we should. Doc features, images, townsfolk generator, that's the draw.io file. And here's that. Fantastic. Let's make VS Code bigger. We're collecting those changes there. Good. Let's close our requirement notes and open up architecture. Not the ping. Here we go. All right. So, our static design. And I believe we go image source equals slash doc slash images slash townsfolk gen static arch.png alt equals, let's use single quotes, an architectural diagram of our static design showing the conceptual components that will make up our application. Save. And I want to get a preview of this guy. So, boop. And it doesn't like that much at all, does it? What did I do wrong? Image source. I think I did it right. Did I do it right? I mean, it's got a broken image. Here's the townsfolk gen static arch. It really mustn't like the way I tried to do that. That's okay. New window. Markdown, import images. How to display a local image in Markdown. With sizing. That's going to be important. Use the image tag, set the source attribute to the URL obtained, set the width and height attributes. All right. Show me the code, please. Because that didn't really work well with height. All right. Yeah. I don't like that answer. No, sir. Okay. Let's just fly it in the normal way. Add image to Markdown file. Java T-point. Oh, you know what? I have a whole bunch of coding cheat sheets. Syntax highlighting. Let's go all the way to the top. Up. Oh. What's that? That's our Git cheat sheet. Ultimate Markdown cheat sheets. Syntax, links, images. Bam. Alt text and title are optional. Alt text image. Image source. Okay, we must have to use the hard URL for that. Theme using picture tag. Yeah, it really doesn't seem to like that very much, does it? That's all right. Goodbye. Sure, yes. Close. So let's try it this way. Alt text. And I think it's like this. /docs/ No, it doesn't like that at all. Parens? No, that'll build us a link. Rob. What are you doing? New window. Here's Safari. Add image to Markdown. How do I display a local? Let's just go to Stack Overflow. It's an exclamation point, I think. No, that's the I am unsuccessful with this. So how, oh, come on. I don't want to just go away. Cancel, because it was in my way. If you have spaces in the file path, they have to be URL encoded. Oh. Do I have URL encoding in that file name? Or is that file name in a weird place? Townsfolk gen /static arch ping. And is there actually a parenthesis or a hyphen there? Nope. All right. That's 850 by 615. That's going to be gigantic. That's going to be huge. That's okay. All right, I was kind of on the right track here. I'm going to do that. /docs. Doc. Doc / images. Save. alt text will be static architecture diagram showing the components of our townsfolk generator. Save. And we've got all the goodies. All right, so when we go to generate a townsperson, we're going to call into the manager. The townsperson is going to create an empty NPC. And it's going to first say, okay, we need this. Then we need this. Then we need this. Sometimes we'll be applying it. Sometimes we won't. Or sometimes we'll be providing those values. Sometimes we won't. And we'll actually sort through that algorithm and the workflow in C#. And we already know we want these components. So let's start that setup process. First thing I want to do, added static architecture diagram for app and linked it to our arc.md file. Let's close that. Detailed designs. We can't do details until we have an idea of what we'll be building. We'll likely do these detailed designs inside the application, then document them here as we go. Once the basic building blocks have been added to our application, we'll document who depends on what here. Save it. We're going to commit to specification and documentation branch. Okay, do it. We've synced. Let's head to GitHub. That guy is about to get closed. We need to add an item. Create the dotNet solution in our repository. Add the initial projects to it. Bam. Assigning me. Good. Convert to issue. GM tools. There's no milestones here. Labels. Let's call this coding. And a little bit of infrastructure work. Let's edit this. We finally get to use VS Code for something other than markdown, documentation, and planning. Add GM game tools .sln src slash, I actually need that draw.io. I need that back. Come on back. Open existing. And we got to go to code, tools, doc, images, this guy. Here we go. I'm going to pull this off to my other machine, or my other screen here. So source slash console client slash client.cs proj src slash game tools slash managers townsfolk manager dot, actually no, let's call this NPC generator. No, townsfolk manager dot game tools dot townsfolk manager dot cs proj. Yeah. src slash game tools slash engines slash game tools dot dice engine dot cs proj. CS proj stands for C# project, not ARC but SRC. SRC slash game tools, slash access resource access slash game tools dot rule set access CS project. I'm going to come back to the start, copy it, paste it, and this will be NPC access. All right. Save. Let's go back to code. All right, good. The commit is done. I'm going to come up here. Go back to my repository. Here we go. I'm going to do a pull request on all of those documentation changes we did. We are going from specifications and documentations into main. We've added enough documentation to be able to lay out our dotNet solution and its project structure. Now, and like a dummy, I did not tag that issue for the planning anywhere. This is number 5. This PR will close issue number 5. Now, just because we're closing all of these documentation tasks does not mean that we're done with documentation and planning. It means we've gotten our planning and our documentation to a point where we can actually do something material. We can start setting up the structures that we'll be developing within. Let's go ahead and merge our pull request. Confirm. It's doing its thing. Let's go back and make sure that all of our code and all of our changes are where we want them to be before we go deleting a branch. Here's all of our images. Here's that. Architecture. Looks mostly good. I want to fix the way that looks real quick. I'm just going to edit it in place. All right, commit changes. Fixed the markdown to make the heading look right, and just commit it directly. I know that's a sin. It'll be an extra poke in the butt with the pitchfork when I go to the developer afterlife. Our requirements, they're looking all right. Our features, townsfolk generator, all right. And our README file still looks pretty all right. Supporting documentation. Yeah, we might update that at some point. Good enough for now. So let's go to our pull requests. Actually, no. Incorrect. I want to go to the branches list. And I like to keep my branches pretty clean. This says it's behind by 3. I don't feel like that's necessarily accurate. All right. It's doing that. Let's flip to main. Let's sync all of the changes down. Do it. Here we go. I'm going to go back to our branch, features and specs. Here we go. And I want to do git merge from main. What changes have we got? Update architecture. Oh, yeah. Let's just sync the changes. Okay. And then I'm going to do another pull request again, just to be absolutely certain that I got it right. Branches, we're still behind. That's silly. Okay. We're no longer behind or ahead. I don't have to do a pull request because these two branches are now identical. We're done with specs and documentation for the time being. So let's get rid of that branch. Goodbye. Back to code. We'll go back to main. And get new branch. We're going to create it from main. And we're going to call it feature/solution setup. Great. We're not going to publish the branch yet. There's nothing in the source file. That's okay. For this stuff, we're going to need to use a terminal window. So we're in GM Tools, CD source, ls, nothing up my sleeve. And prior to me becoming in between positions. I was very, very, very used to Visual Studio where I could go right click, new, solution, or whatever. And I can't do that anymore. And it's a big drag. So I'm going to have to use the command line .NET CLI cheat sheets. Yep, I need the cheat sheets. And I can't remember what all of the command line thingies are, all of the switches and so on. And this cheat sheet is absolutely hideously formatted. Ew. All right, so let's say .NET new solution -- help. You gonna give me some goodies? Okay. So we got to give it a name. We got to give it some options. There are no template options. That's fine. So let's do this. .NET new solution. And I have to type over here, not in the Streamlabs window. .NET new solution -n game tools. Do I need to give it the full name? I can't tell. Seems to be gametools.sln. -o, I believe, is dot. And let's do a dry run and see what it tells us. File actions that would have been taken, create gametools.solution.solution. That doesn't. Okay, so we know we made a mistake, and that's okay. We don't need to specify that. Let's try evaluating that command. Good deal. Let's run it one more time without the dry run. Engage. We now have a solution file. Fantastic. And because we now have a solution file, and I am running the C# dev kit extension inside Visual Studio Code, I might be able to avoid having to use command line stuff to add all these projects, which would make me very, very happy because I've gotten old and I'm very used to the I've gotten very, very used to doing things with the clicky. I gotta mark this, our first static design, as done just before we carry on. We gotta come in here, and I want the list of stuff, so I'm just gonna pull this over to my other monitor here real quick. And then as soon as we're done with this, we're going to check it all in and be done for the day. Tomorrow, we'll start sketching, like sketching in code. So because we've got the C# dev kit installed to Visual Studio Code, I should be able to rename, delete. Nope. What is going on here? GameTools.solution. Here's all this stuff. Debug, solution properties, pre-solution, hide solution node equals false, and global section, yeah. There used to be a open solution. Duh. And I should have, oh, there we go. It's doing all the things. Is it still thinking? Where's my grabby? Receive name pipe information from the server. Boogity boogity boo. Activating the C# dev kit and the IntelliCode and all that good stuff. Good. And we should be able to shrink this and load our Solution Explorer. And it looks like we might be having a little bit of a problem with VS Code right now. C# dev kit. We're good. We're not going to use any remote repositories or any of that nonsense. Nope, go away. All right. But in here, we can add a new project. And it's going to be a class library. And that class library is going to be called we got to escape first. GM tools under source. Let's add a new folder. We're going to call it managers. We're going to add another folder called engines. And another new folder called resource access. And one called utilities. Which may remain empty for a good while. All right. Let's shrink this back up. Here we go. Let's add a console app, and we will call it console client. Enter. Escape, because I mistyped it. Add console app. Console client. Yes, we want it in the console client. Project will be created in the console client folder. Good. I guess I panicked for no reason. Is it going to let me pull this stuff around here? I want to make this bigger. Open editors. All right, now let's add a solution folder. Managers. We'll add another solution folder called engines and another solution folder called access. Now there's a difference between solution folders and physical folders. And I used to only use the solution folders inside the inside Visual Studio to keep my conceptual components in their little happy spaces. And it was pointed out to me that actually mirroring the solution folder structure at the physical file system is a lot cleaner and more helpful to other people that might be looking at my solutions. So that's why I've created those actual physical files out here at the file system level. Let's go in and add a new project to our resource access folder. It too is going to be a class library. Resource access / class library. And we are going to call it, what are we going to call it? GameTools.npc access. New project, class library, / GameTools .npc access. Let's choose another directory to place this. Here we go. It's going to go in here. Yep. Select that. All right, good. Create it. And there's that. It's even got a class in there for us already. Let's add another resource access. It too will be a class library. And it's going to be called rule set access. And it's going to get pushed into the resource access physical folder. Do it. Engines. What do we decide to call our dice engine? GameTools.diceEngine. Let's add a project. Another class library. GameTools.diceEngine. Create project. Good. Now, our view is starting to get a little goofy over here, so I want to just close up these solution folders a bit. Managers has nothing in it. We're going to add a new project to our managers. Yet another class library. And this should all be starting to look pretty repetitive and mechanical. GameTools.townsfolk manager. It's going to go into the managers folder. We've got our solution name .townsfolk manager. Create the project. Great. Now, we don't do anything yet. Our console hasn't got any dependencies. I believe it just says hello world. We could probably run this. Can we set it as a startup project here? No, we can't, but we can debug it. We can start without debugging. Here we go. MS build, it's doing all the things. All projects are up to date for restore because it doesn't have any. Developer tools access is trying to take control of another process. Yes. It wants my system thing. And there's hello world. Good. So that works. Console client is exited. Yeah. Run and debug. All right. Can we build? We can. Let's see what happens when we build. All right, we're running dotNet build. We don't have anything to restore. It's doing the things. Terminal blah blah blah. All projects are up to date. We built the dice engine. We built MPC access, our console client, our rule set access, and our game tools.townsfolk manager. Now, Rob, you might ask, why did we create 1, 2, 3, 4, 5 dotNet projects? Hey, we've got our things back. When all we want to do is randomly generate a townsperson. Well, that comes back to some things we have over in our requirements. In particular, our technical requirements. The components we create should be as reusable as is practical. And if we bury our dice engine just in a console application or inside the manager, and then we decide we want to use our dice engine when we're rolling for initiative in another service, then we're going to either have to reference the townsfolk manager from the initiative manager, and we've already discussed that that's a no-no because we never do manager to manager calls directly. So if we put our dice up in the dice engine and we decide to add an initiative manager, then that initiative manager just needs to reference the dice engine instead of, pulling in the townsfolk manager and hacking our way in, because the dice methods inside townsfolk manager probably aren't going to be public. So we would have to do either some weird reflection stuff, or we would have to change our public interfaces on the townsfolk manager, and that's a big no-no. We don't want to do that. We want to keep, once we've established what the townsfolk manager looks from the outside, we don't want to change that too much. And we want that statement to be true for all of these component projects. So we've gone over a little bit today by just a few minutes, but we have our solution stub. We've got the projects created. We've opened VS Code. Projects and solution have been created. Commit. We're going to do one last thing here, friends. We're going to publish this. We know our build works. We know we can at least run the console client and it says hello world. That's all good stuff. Let's bring up GitHub. Where are we? Here we are. Oh, another reason for putting these things in the other in their own projects. We may need to move some capabilities into their own component areas. Perhaps even run them as separate background services. Just because we have our capabilities in different projects right now does not mean we're pursuing microservices with this. You'll see tomorrow when we study the dependency, when we talk about the dependencies between one project and another and how we add our references, you'll see that we're actually building a monolith, a small monolith, more like just a little yard statue, maybe a garden gnome instead of a monolith. But inside that garden gnome architecture is a well-factored set of components that we're just composing together to give us the features we want. We'll get there, one step at a time. So I wanted to come up to GitHub, and I want our issues. I need the ID from this. It's number 8. Very good. Let's attach this guy, excuse me, to a branch. Here's the repository. Here's the branch. Let's apply it. Very good. And this is issue number 8. We'll go back out to code. Solution setup had recent pushes 2 minutes ago. Let's compare and pull request. Created the dotNet solution. Added the class library projects that will form our components. This will close issue number 8. Create pull request. And we're checking for the ability to merge manually. We are all good because there are no conflicts. This is brand new. Merge the pull request. Confirm the merge. And we should be able to delete that branch. Excellent. All right, folks, we got some progress down today. It may not look like it, but we've made some solid progress. So what's our progress look like? Yesterday at 10 a.m., we had a problem that I described that I have when I run my D&D games. We came up with an idea. And then we set up our project in GitHub to track the progress of us planning, like gathering the requirements, figuring out what is and isn't important for this project. And then we analyze those requirements to see if we could harvest some software concepts that we could then turn into actual software components. We analyze those components to make sure they're going to stand the test of time. And then finally, we formalized the names of those components on our static architecture. We figured out what is approximately going to go where, and we created our dotNet solution and checked it in. Not bad for 4 and a bit hours work. Tomorrow, we're going to start by analyzing our dependencies between these projects, and we'll make some notes on those. And then we're going to start working on the DICE engine. Until then, be good to yourselves. Don't beat yourselves up too much. We all make mistakes. You saw plenty of that over the past few days. And drink water, eat good food, get fresh air, touch something green, and I'll see you tomorrow.